All right, chemists. So now we're going to take what we learned in the last lesson about Avogadro's number and apply it less the idea of that 6.02 times 10 to the 23rd and more the idea of moles, that mole concept and molar mass. So we learned a little bit about molar mass last time when we talked about 1 mole of a substance is equal to the number of grams. Sorry, I need to explain this better. The molar mass of a substance is equal to the atomic weight of that substance from the periodic table in grams. So you can figure out, that's a can, figure out the mass of 1 mole of a substance or compound using the periodic table. So a mole of solid or liquid is generally the amount you can hold in your hand. We saw that today in class. And a mole of gas at 1 atm and 0 degrees C is always 22.4 liters. I remember back when I was in high school, we actually had to memorize that number. So there's the math that goes behind it. So any gas, doesn't matter what the identity is, at 1 atm and 0 degrees C is always 22.4 liters. So this gives you an idea of the scale of what 1 mole is. So here's the pun of the day. As you saw in class today, when we did aluminum, 2 cans of aluminum is equal to 1 mole of aluminum. So we have a 2 can, 1 mole. Isn't that awesome? Going to credit Mr. Hamill with that one. All right. So some of this math from class today, I'm just going to review this a little bit. We were measuring out 6 cans of aluminum. Well, our conversion factor that we had was 2 cans for 1 mole. So my ratio is 2 cans. I put cans on the bottom because that's what I want to cross out to 1 mole. And I know if I have 6 cans of aluminum, I get 3 moles. So I'm going to jump ahead to number 3. And if we have 2.5 moles of H2O, well, I know from the periodic table, well, H2O, to find the molar mass, I have 1 oxygen atom, so 1 times 16 is 16 grams. I have 2 hydrogen atoms, 2 times, and each one of those is 1. So 1 mole of water is 18 grams. So I'll put moles on the bottom, grams on top. But now that's not what it asked me. And this is the first time that we're using multiple conversion factors in a row, so you can see why I want you to keep it all in order. Then I know 1 gram of water is equal to 1 milliliter, because that's the density of water. So the grams cross out, and I get 2.5 times 18 times 1 is going to be equal to, oh, sorry, it was 25 moles, not 2.5. So 450 milliliters, everything else crossed out, so that's my answer. So see how we can use these conversion factors in a line and multiply across the top and divide along the bottom. So H2O I just told you was 18 grams per mole, but how about a bigger one, like sugar? How would I calculate the molar mass of sugar? Well, I have in one molecule of this, I have 11 atoms of oxygen. So that's 11 times 16, which is 176. I have 22 atoms of hydrogen. Each one of those is 1. So that's 22. And I have 12 atoms of carbon. Each one of those is 12 grams per mole. So that's 144. So I add this up, and I get 1 mole of this sugar is equal to 342 grams. That's how you find the molar mass of a compound. You just take all the constituent atoms, multiply them by their molar masses, and sum them all up. Okay, how can you convert between mass and moles? Well, the molar mass of a compound is the sum of the atomic masses of each atom, as I just showed you. And the molar mass is a conversion factor, basically a ratio that allows you to convert between moles of a compound and grams. And I'm going to put one last thing in, that the value for moles when you're doing your conversion is always less than the value of grams. So that's like the logic I want you to think with. You know, unless the only time this isn't true is hydrogen, but for everything else, if you have 2 moles of a substance and you calculate the grams and you get less than 2, you know your answer isn't right. That's not logically making sense. But if you have 2 moles of a substance and it weighs, let's say, I don't know, 48.6 grams, then you know it's magnesium.